grade 12 learners. Welcome to today's Physical Sciences lesson. My name is Dimpho Rampora and this lesson is brought to you by the Northern Cape Department of Education in collaboration with Bagama Research and Development. For today's lesson, we are going to be looking at the topic mechanics and we are going to be zooming into Newton's law. Okay, now what is it that we need to know in this chapter? Now remember, by the end of this lesson we need to be able to focus on the following. We need to be able to define normal force, friction force, static friction force, as well as kinetic friction force. We also should be able to state Newton's first law, second law, third law, as well as the universal law of gravitational acceleration. We also should be able to differentiate between the free body diagrams, force diagrams for objects at equilibrium and objects that are accelerating. Now we further need to be able to determine the result of two or more forces, and we also need to be able to discuss the importance of wearing seat belts, and furthermore calculate and solve problems using Newton's law equations. Now we don't end there. When we know now the learning objectives of today's lesson, we are quickly going to jump into the grade 12 examination tips on Newton laws. So these are the exam tips that I want us to familiarize ourselves with when we are dealing with this chapter. Now, what are the exam tips that I want you to know? Firstly, I want you to know the framework of paper 1. Now remember that paper 1 consists of 10 multiple choice questions which are equivalent to 20 marks. And what you need to know is that the structured questions are equivalent to 130 marks. And all of this gives you a total of 150 marks, and you will be writing your final exam for 3 hours. Now, what else do I want you to know is that the manner in which your question paper will be structured will be structured in different weightings of cognitive levels. And the following levels is what you're going to be seeing in your question paper according to the exam guideline. So you have cognitive level 1, which is remembering, where you have to define certain things. Number 2, you need to be able to understand, and then level 3, apply as well as analyzing, and 4, you need to be able to be evaluating and creating synthesis. And your paper consists of the following percentage in terms of the cognitive levels: the 15th, the 35, the 40, as well as the 10%. Now you don't need to really worry about that. It's just for you to know that your paper will definitely be balanced when you see it. Now the next thing I want us to look at is the weightings of the prescribed content, so that you know how much work you need to put in as you prepare each topic. Now remember, the topic that we are going to be looking at is Newton laws, so it is under the knowledge area mechanics, and mechanics in paper 1 carries a lot of marks. As you can see, it carries up to 65 marks, and then out of that 65 marks, we have other knowledge areas such as wave, sound, and light. We also have electricity and magnetism. We also have matter and materials. And as you can see, mechanics is the one with the highest marks in paper 1. And if we understand mechanics better, then it will be easy for us to also know the other knowledge areas. And again, you'll be given out of 150 marks when you combine all the knowledge areas. Now, for the sake of today's lesson, we know that we are dealing with Newton laws, but basically, this is normally question 2 of your previous question papers. And remember that Newton laws was done also in grade 11, so you're doing it like really for the second time in grade 12. So this chapter is there in grade 11 also. So that is what we are going to be zooming in. It is mostly 20 plus minus 20 marks in question 2 that you need to work hard for. Now, what is it that you need to know in terms of this chapter? Definitions are very important. We still need to know how to define Newton's first law, second law, as well as the third law, the universal law of gravitational acceleration. We need to know what is a normal force and how to identify the friction force, the static friction, the kinetic friction force. These definitions, any of these, the examiner can choose to ask you. So you need to know all of them in order for you to be safe. Another exam tip that I always give you, I'll always say to you, it's very important to prepare a mind map. Now, a mind map sort of gives you an overview of what you have to memorize or what you have to study as you are looking at this specific chapter. So over here, I've done the mind map on Newton laws and forces. What I want you to remember is the Newton first law, where you remember that F net is equals to 0 over there. And remember, during Newton first law, an object is either at rest or moving at constant velocity. So when you see the words at rest or moving at constant velocity, you know that you are dealing with Newton's first law. In Newton's second law, we do know that F net cannot be equals to 0 because the object is moving and the object is not moving at constant what? Acceleration. Alright, so F net cannot be 0. Therefore, your F net must be equals to ma. Very important to consider. And lastly, Newton's third law. Here we are looking at two bodies. What you need to remember is that force A applied on B will be equals to force B applied on A, but in opposite what? Direction. Right. I hope you guys are still together with me. And then in more tips that I'm giving you, again, I want you, if you don't know how to do the mind map, you can also use a flow diagram like I've done here to just look at Newton's first law. What is it that you must know on Newton's first law? What is it that you must know under Newton's second law? And what is it that you must remember also on Newton's third law? All right. Now, what I want you to remember is NB. See, I already made you an NB there, which is very, very, very important. The object experiences zero acceleration when F net is equals to 0. And remember, F net is equals to 0. It's always associated with Newton's first law. All right. Very much important to remember that. Now, these are some of the common errors that I'm making you aware of as you are going to study for your final exams. These are the one of the common errors that we find when we are dealing with this chapter. One, most of you think that because there is constant motion, that means that constant motion is equals to constant force. Now remember, that is not the truth, because many believe that the moving object requires continuous force in order for it to move, but we know that that is not the case. Sometimes the object might be moving, but it might not be moving at a constant motion. So it's not always the case. Now, zero force is equals to zero motion. This is not true, because most of you think that if there is no force, the object must be at rest, and this is incorrect. Remember that if there is no force, it doesn't mean that the object is at rest. It can also mean that the object has been moving, all this time, and you find it moving. So you can't be saying now there is no force that the object is experiencing. And again, you are confusing the net force. The phrase no net force is often mistaken for no force at all. Remember, if we are saying F net is equals to 0, it doesn't mean that there is no force. Okay, there are forces that are acting on the object, but it's just that the object is either stationary or moving at constant velocity. So we then say acceleration is equals to 0, but we still have forces that are acting on the object. Okay, that is very, very important to take note of. The following exam tips that I'm giving you is the keywords that you need to look at when you are dealing with this chapter. Now, the first keywords that I want you to look at is when you see rough surface. Okay, when you see the word rough surface, just know that that means friction is there. That means when you are drawing your free body diagram or when you are doing your calculation, you must include what? Friction. So that is the keyword that the examiner is going to give you. Another keyword that the examiner can give is frictionless surface. So the moment you see frictionless surface, the examiner is trying to say to you, please ignore the friction force. All right, do not include friction as you do your calculations. And then another one is constant speed or constant acceleration. The moment you see on the statement, you are reading the statement and they are telling you that the object is moving at constant speed or constant acceleration, then you now know that F net will be equals to 0, because acceleration there will be 0 according to Newton's first law. Right. Now that I looked at the different keywords that you need to look up to, the next exam tip that I want to give you is how to draw the free body diagram, or how to sketch the force and the free body diagrams. Okay, what is it that you must look at? You must be able to distinguish first the differences between the free body diagram and the force diagram. Very much important for you to know the difference. Another thing is the mark allocation is a guide to the number of forces required in the diagram, right? For example, the examiner can say to you, draw a free body diagram or draw a force diagram. Then when you look at the mark allocation, you see there 4 marks. What does that mean? 4 marks is always 4 forces. So that means that you need to label the 4 forces that you can give as you are drawing the free body diagram. Now, another tip I want to give you is that if you add any extra forces and you are leaving out some of the arrowheads and the arrow and your arrows, they don't touch the line as you are drawing your free body diagram. So let me just make an example. If you are drawing your free body diagram like this, as you can see, like this over here, this is just a straight line. It doesn't have any arrowhead. So the moment there's no arrowhead and it's just a line like that, just know that you will be penalized for that. Remember that when we are dealing with a force is a vector quantity. It needs to have magnitude and direction. The arrowhead indicates the direction at which the vector is moving in. So it's very important to always include the arrowhead and make sure that the arrowhead touches the line, because some of you, when you draw the free body diagram, you draw it like that, and then there is a space between the arrowhead and the line. You would be penalized for that. So make sure that you draw a clean and neat arrow that shows the arrowhead. Okay, so as I said, that this can result in you losing the marks due to negative marking, or maybe being penalized because you did not follow the rules of drawing the free body diagram. Now you also need to label the forces correctly. Okay, use the correct symbols as you name the forces. For example, the normal force, we know we use capital letter N to represent the normal force. Please use the correct symbols. That is what is going to guide you. And remember, all the symbols, that if you are not sure about them, you can always visit your exam guideline, which is the 2021 exam guideline for physical sciences. You should get all the necessary information regarding which symbols to look out for. Now, the next exam tip that I'm going to give you, this one is definitely going to give you a pass at the end of the year. What is it that I want you to look at? Here, I've made a table where I want you to look at the different scenarios at which the examiner can be giving you the object, or the object might be lying on. Okay, so you need to know how to deal with all the different scenarios that the examiner might be able to give you. So over here, I also gave you a diagram in terms of the diagram as it appears on the question paper. Here I gave you the force diagram. How do you draw the force diagram and its free body diagram? And I've also given you what you need to put under FNet is equals to MA. So as I'm saying, that this one is definitely going to give you a pass, because this is what is going to help you as you are dealing with your Newton's second law. Now, firstly, you have a force there. You have a block on a flat surface, as you can see, and you have a force applied to the right hand side. Now, the first thing that you need to look at, the moment you see, a square, something like that, you can see that means that my surface is rough, okay? But sometimes the examiner can always tell you if the surface is rough or not, if you are not sure. So the surface there is rough. Since the surface is rough, that means that I have friction. So what is the first thing that I'm going to do? When I draw a force diagram, remember, you are drawing the force diagram, you are showing us the exact position of the forces according to their definitions. Now, here is my force diagram over here. I have that force applied that is going to the right hand side, which is that one. I have weight, or Fg. I know that others are writing it as Fg. So that weight, or Fg, is always going to start at the center of the block, pulling it downwards. Okay, remember, this is a force diagram. You need to show the exact position of the force. Another force that you have here, you have your normal force over here. Remember, the normal force is the force that is exerted by the surface on the object, and it must always act perpendicular to the surface. So very important, as you draw the force diagram, it must show that it starts from where the surface is, because it is a contact force between the surface and the object. Okay, and then lastly over here, we have a friction force to indicate that there is a motion, there is a force rather that opposes the motion of the object. As you can see from the diagram, we can see that the force applied is going to the right hand side. If we assume that the force is going to the right, the object is accelerating to the right hand side, then the friction force must always oppose the motion of the object. Guys, this is how you draw the force diagram. And can you see the differences between the force diagram and the free body diagram? On the free body diagram, you represent the object with a dot. There you have it there. And then remember the rules. The arrows must always face away from the dot. There shouldn't be any arrow that must be facing towards the dot. If you have an arrow that is facing towards the dot, just know that you would have drawn an incorrect free body diagram. All right, very important to remember. Very, very clean. As you can see, make sure that your normal force is perpendicular to the surface. Make sure that your normal force and the weight are equivalent to each other, as you can see from the free body diagram. Now, the next thing is, what should we put under F net is equals to NA? So here we are going to assume that the object is moving. If the object is moving and is not moving at constant velocity, so we are going to assume that we have acceleration, even though we don't know how much acceleration is it. Now, what is important is what must be here under F net. Remember, F net is the sum of the forces that are acting on the object. Specifically, I would always say where the motion of the object is. Always look, where is the motion of my object? Is it moving horizontally or is it moving vertically? All right. So in this case, the motion of our object is going horizontally. That means that those are all the forces that are acting on the object, causing the object to do what? To accelerate in the right hand side, right? I hope you know that. That's why over here we have the force, which is that force. We have friction force, which is that, which goes in the opposite direction. Another thing that I want you to remember is that when we are dealing with Newton laws, we are dealing with a vector, okay? So it's very important that you always choose direction all the time. All right, so I'm just gonna be using only one example, which is the horizontal, to explain in detail, and then the rest of the others I think you'll be able to do it on your own. So the vector, remember Newton laws, vector, it is a physical quantity that has magnitude and direction. So it's very important that you must always include direction. That's why, as you can see from here, I have chosen right hand side as positive. Hence my F over here is positive, and because my friction opposes the motion of the object, it will be going negative, and it also opposes the direction that I have chosen. So very important that you must always be consistent with your direction. Another thing that I want you to take note of is that NB, it indicates the exact position of the force acting on the object. What indicates that? It is what we call the force diagram. The force diagram always indicates the exact position of the force acting on the object, while the free body diagram, you just indicate the object with the dot, and all your arrows must be moving away from that dot. Okay, very important. And then lastly, it's very important to know what should be your normal force given the scenarios that you are given. So over here, your normal force will be equals to Fg. Why is the normal force equals to Fg or weight? Because the normal force and the Fg are balanced. That is what it is keeping the object on the surface, and so that the object can be either accelerating to the right or accelerating to the left. All right, very, very important to know that. So the normal force in this scenario will be equals to the weight of the object. Now scenario number 2, you can see here I have a force again, but the force now is acting at an angle. If you have a vector that is acting at an angle, what you need to do when you draw the force diagram, you still follow the rules of drawing the correct force diagram there. You put all the forces where they are supposed to be, and then when you draw the free body diagram, please make sure that you draw the force at an angle. That is what we are looking for. Please, we are now going to be penalizing if you are including the components. Please don't include components like this on top of the force. So when you draw the free body diagram, you always draw it without the components. All right, remember, you will always put the components only when you are doing your calculations. Please bear in mind with that. Okay, Very, very important. Another thing is under F net is equals to MA, because our force is acting at an angle. When you are going to be substituting under F net, remember that force, it's that force that is acting at an angle, okay? So assuming that that is the angle of 20 degrees and that is the force, how do we resolve a vector? Remember that is acting at an angle. We will always break it down into components. What are the components of this F? It will be Fy sine theta over here and Fx cos theta, okay? Why do we have F sine and F cos? Because we are looking at the angle from the horizontal, okay? If we have the angle from the horizontal, we know that is going to be our cos and that is going to be our sine. So when we are going to be, so that means here our horizontal component will be Fx cos theta. So don't forget to include Fs cos theta as you are doing your calculations. That's why here I put for you F parallel, which is F cos theta minus the friction force. That is what you are going to be putting here. If you put F, which is this, and then you say minus Fk, this will be incorrect because F is acting at an angle, and to resolve it, we must always break it down into components. And what is the horizontal component of this force? The horizontal component of the force is Fx cos theta. Very important to know, very, very important to remember. And then I also made a simple note for you here. Right, the next NB that I just showed you here is just what I've been saying, that remember when you are representing a what? A free body diagram, what you must remember is that you represent the object with a what? With a dot, okay? The rest we've already discussed it. Guys, you can see here, these are all the different scenarios that you need to familiarize yourself with as you are dealing with this chapter. Very important here, you have a force that is coming at this direction, okay? So when you draw the free body diagram, you're not going to draw the force like that, because remember the rules of the free body diagram is that the arrow must always face away. That's why we have our F going that other direction, because the arrow must always face away from the dot, okay? Take note of the normal force over here. The normal force is not only going to be equals to Fg, because we have the component of what? Of F. So it will be the normal force is equals to the weight plus the Fg perpendicular, all right? Very, very much important to remember. The Fg perpendicular will be your F sine theta, okay, which is the vertical component. All right, guys, again, you can be given a scenario where you are only dealing with a vertical object like this one, any object that is hanging. Remember, when you are dealing with the object that is hanging, there is no surface. That means there won't be any normal force. There will be only two forces that are acting on the object, which is the weight and the tension. Very important to remember. And then that is how your free body diagram is going to look like. And under your F net, that is what you are going to put. All right, remember here you must choose either the direction, if up is positive or down is what? Is positive, and you must be consistent with that direction. Very, very much important. Again, over here you can be given an inclined plane. When you are given an inclined plane, please make sure this is the correct way to draw the free body diagram. Do not include the components. You see, common mistake that we normally do when we draw our force diagram is this one. Please let us stay away from it. So do not do this one. Do not do, okay, in this final exam. Please don't do that, okay? Why? Because we are only interested in weight. We are only interested in weight. So even if you have a surface that is acting at an angle, when you draw the force of gravity, you always draw it going vertically downwards. You do not draw it with the components, but you can always draw the force diagram or the free body diagram separately after you have drawn the actual diagram that the examiner was looking at. Then in that force diagram, then nothing is stopping you from including your components, because you want to include them here as you are doing your calculations. So over here we have force, which is going up the incline, minus F, which is going down the incline, because they're in opposite direction. And don't forget to minus the component of Fg rather, which is Fg what? Parallel. So the component of Fg is Fg parallel, or its weight parallel, which are very important to consider as you are doing your calculations. All right. Guys, now another tip that I want to give you still on the free body diagram is that only include components when starting with what? With calculations. I think I've emphasized it enough. So when you draw a free body diagram for this one, what do I want you to do? You draw the normal force over there. You will draw your weight or your FG. You draw the force F at an angle, and then you draw, sorry about that, you will draw your friction force over there. All right. Remember, guys, it is very important that you do not include the components. You only include them when you are doing your own calculations. Very, very important. Now, another exam tip that I want to give you is that when you are given more than one object, you see in the previous slide, we were only dealing with one object, but the examiner can give you more than one object. Then what do you do when you have to draw the free body diagram? The tip that I give you is that you must draw a free body diagram for each block or for each object. For example, in this scenario, you have B and you have A. What does that mean? You need to draw the free body diagram for B and also draw the free body diagram for A. And over here, you have this 3 kg and the 6 kg. Again, what you do, you draw the free body diagram for 3 and draw the free body diagram for what? For the 6. And then also here, you have the X and the Y. You also do the same. You draw the free body diagram for those ones. All right. Very, very much important to consider. Now, the following is from your exam guideline. This is also another tip I'm giving you, that you must always check what is it that in this topic the examiner is going to ask me in terms of Newton's second law. Now, the examiner can either ask you a question where you are looking at a single object moving on a horizontal plane with or without friction, or you can be given a single object on an inclined plane with or without friction. So you already know with or without friction, the keywords are going to assist you. Moving in a vertical plane, lift, rockets, and etc. But you are not only going to be focusing on only one object, like I showed you in the previous slide, that they can be two body systems where they are connected together with a string. Then what do you do when you do that? The examiner is going to be saying, apply Newton's second law by looking at both on a flat horizontal plane with or without friction, or one on the horizontal plane with or without friction, and the second one would be hanging vertically downwards. I think this one we looked at it. So that would mean if you had a table there, you have an object, and that is a pulley, and the other one will be hanging. That would be this scenario. Both on the inclined plane with or without friction, both hanging vertically from a string over a frictionless pulley. So these are all the different scenarios that you need to go and practice, because the examiner can ask you based on any of those scenarios. So you need to familiarize yourself with. Guys, my exam tips don't end, because I want you to do well in this chapter. The other exam tips for Newton's law is that you must remember that this topic is assessed in paper 1. You know, sometimes we are confused if am I doing paper 1 or paper 2. So please remember, Newton's laws is paper 1, okay, which is physics. Then another thing is that you need to copy the formula as it is written on your data sheet. Normally, when you get the question paper, you get it with the data sheet, you get it with the formula sheet. Please make sure that you copy the formula as it appears on the data sheet without attempting to manipulate it first. Do not manipulate the formula, manipulate rather your substitution to solve for whatever x that you are supposed to solve. Now, another thing that I want to make sure is to ensure that all values are in SI units, and all your SI units are correct, especially in this chapter. You know, you confuse normally meters per second with meters per second squared. Remember, meters per second, we are talking about velocity or speed, and then meters per second squared, we are talking about acceleration. Okay, please take note of that. It is very, very, very important. Show all your substitutions, take the correct formula and substitute correctly. That is what we are going to be interested in. Include the correct unit for the answer. I think I already emphasized that one. Now, what is it that you need to do the moment you see a question on Newton's laws? These are the steps that will help you to solve the problems, or solve calculation problems as you are dealing with Newton's second law. First, you need to read the statement, read it with understanding, make sense of the statement, and draw a diagram. If you are not given a diagram, read the statement, make sense of the statement, and draw what the statement is saying. Then draw a force diagram with all the forces acting on the object so that you know which forces will be on the field body diagram. The direction in which the object or the system is going should be taken as positive. This is the advice that I'm giving you, that take the motion of the object as positive. But there's nothing wrong when you say you want to take the direction of the motion as negative, as long as you are going to be consistent with it. But this just makes more sense to say, let's take the direction of the motion as positive. Apply Newton's second law of motion equation. Very, very important to do that. And then last but not least, I want us to familiarize ourselves with the data sheet or the formula sheet. What is it which formulas rather am I going to be using in this question? This is the first formula, the main formula, of course, that you'll be using as you are calculating Newton laws. And remember, F net is equals to ma is Newton's second law. But the moment you put acceleration as 0, it becomes F net is equals to 0, because any number multiplied by 0 will give you 0, and this one will be Newton's first law. Now, you will be using this formula of Fx max is equals to the coefficient of static friction multiplied by the normal force when you are calculating a static friction, okay, friction force, okay. Now here, which equation do I use here? This one I'll be using as you can see, they are almost similar. They are both formulas for friction. The difference is that one, the other one is for static friction, while the other one is for kinetic friction. So for kinetic friction, this one is for kinetic friction force, okay? Friction force. Very, very much important. Another formula that you are going to be using is W is equals to mg, which is the formula for what? For weight, or should we say force of gravity. Okay, very important to know which formula do I use where. Okay, then over here, this formula over here, you'll be using it for universal law of gravitational acceleration. Universal law of gravitational acceleration. Okay, that is where you're going to be using it. So for this is what I only want you to know in terms of the exam tips that I've given. Now that we are done, we have come to the end of our examination tips. So let's quickly take an air break, and when we come back, we are going to be looking at more exam questions now. We will be dealing with that.